Have you ever looked at a massive industrial machine, one that can bend solid steel like it's paper, and wondered how it gets things so perfectly accurate, down to the micron? Well, it's not just about brute force, it's about intelligence. So today, let's dive into this hidden world and talk about the real hero of modern manufacturing, the CNC Press Brake Controller.
Right, this is the big question, isn't it? How do you take a machine that's pushing hundreds of tons of force and get it to create a flawless part every single time with zero mistakes? The answer is all in this little electronic brain that has totally changed the game for this industry.
And this really shows you what's at stake. It wasn't that long ago that bending metal was more of an art. It all came down to the gut feeling of a master operator. And that meant a ton of trial and error, a lot of wasted material, and a process that was really hard to repeat consistently. But the new way? It's a whole different world. We're talking about data, algorithms, and getting that perfect bend on the very first try with the machine actually guiding the operator. It's a night and day difference.
So let's get properly introduced to this unsung hero. We're going to treat the controller like the machine's brain, the command center that makes all the magic happen.
So what exactly is a CNC Press Brake Controller? Well, the best way to think about it is as the machine's central nervous system. It's not just a screen where you punch in an angle. No, it's a seriously powerful computer that's coordinating every move, processing tons of data, and, here's the most important part, adapting on the fly in real time to make sure every single part that comes out is absolutely perfect.
To really get a handle on how it does all that, we need to peek inside the command center. Let's take a look at the architecture of this brain.
You can think of the information flowing in a really logical sequence. It all kicks off at the core with an industrial-grade CPU. Then all the complex thinking is handled by motion algorithms. The operator talks to the machine through the HMI, or human-machine interface. And finally, the whole thing is connected to the wider factory through its network.
Now here's what makes these parts so cool. That CPU? It's not like the one in your computer. It's all about something called deterministic timing, which just means its calculations are incredibly consistent and predictable, right down to the microsecond. The algorithms are the secret sauce, synchronizing maybe a dozen different moving parts at the exact same time. The libraries are basically huge digital encyclopedias of every tool and material you can imagine. And the HMI? It lets you run a full 3D simulation of the bend, so you can catch any potential crashes before they happen in the real world.
Okay, so we've seen the architecture. Now let's get into the science of how this brain actually tells the machine's body what to do to get that flawless precision.
All right, here is the #1 challenge in bending metal. When you bend a piece of steel, it doesn't just stay there. It always tries to spring back a little bit toward its original shape. This is called spring back, and it is the absolute enemy of precision.
And what makes it even tougher is that every single material fights back differently. You see here, mild steel might only spring back about ½ a degree, but stainless steel, that could be up to 4 degrees. Heck, even 2 different batches of the same metal can behave differently. So you can't just have one simple formula to solve this.
So how does the controller outsmart it? With a brilliant closed-loop feedback system. While the bend is actually happening, a laser system is measuring the angle in real time. That data zips back to the controller, which instantly sees if it's off course. If it detects even a tiny deviation, it tells the RAM to make a micro correction, and this all happens in milliseconds. The result? A perfect angle, every single time. And this quote from one of our sources really just says it all. It's not about how strong the machine is anymore. The intelligence inside that controller has become the single most critical factor for achieving precision in today's manufacturing world.
But this brain power isn't just for precision. It also unlocks incredible speed and efficiency. So let's look at how this brain learns and adapts to make the whole setup process way smarter.
Traditionally, the biggest bottleneck on the shop floor is setup time. For a complicated job, you could have a highly skilled operator spending 45 minutes just finding the right tools, installing them, and getting everything calibrated. That's 45 minutes where the machine is just sitting idle, not making any money.
But what happens when you pair that intelligent controller with an automated tool changer? That exact same setup can be done in under 5 minutes. Let that sink in. That's a productivity jump of almost 90%. For a shop that does a lot of different jobs each day, that is an absolute game changer.
So how does it pull this off? Through a bunch of really smart features. The machine can use RFID tags or barcodes to know exactly which tools are loaded. It can guide an operator, or even a robot, on precisely where to place them and then clamps them automatically.
It even looks at the 3D model of the part and figures out the most efficient, safest way to bend it, all by itself. It's a true partnership between the person and the machine's brain.
But the story doesn't end there with just one smart machine. The real future is all about connectivity, where this brain plugs into the entire factory network. See, this controller isn't an island anymore. It's a critical piece of the Industry 4.0 digital ecosystem. It gets its job orders straight from the company's main planning software. It can log into a cloud library and pull down a program that was designed halfway across the world. It can run entire robotic cells for lights-out, 24/7 production. And it's constantly sending back health data, telling technicians it needs a checkup before it ever breaks down.
And of course, artificial intelligence is making this brain even smarter. The biggest impact right now is in predictive correction, where it learns from every bend it's ever made to get even better at predicting springback. AI also fine-tunes the machine's movements to shave off precious seconds. Then there's adaptive crowning, which is super clever. It actually compensates for the microscopic flex of the machine's own frame to ensure the bend is perfectly straight. And finally, it's crunching all that production data, looking for ways to be more efficient.
So, all of this brings us to a final, really interesting question. When the machine itself has all this deep, expert knowledge baked right in, what's the new role for the human operator? It seems pretty clear the skill is shifting away from doing the manual work and towards supervising the system, solving bigger, more creative problems, and basically managing a whole team of intelligent machines. The collaboration is really just getting started.